check outside the door. See if breakfast came outside the door. Yeah. Why are you reading in my class? Yes, we are. We're going over homework. 27.
First was, I would take that bad. First, that was very bad.
We've already had this conversation about math.
No, you just go downstairs. Right underneath that. I'm not.
All right, antiderivative. Two x minus log x, and I am evaluating from 1/2 to 3. Which means I just plug in the upper limit, 2 times 3 minus log 3. This is a good one. 2 times 1/2 minus log 1/2. Now, this would be a non-calculator problem, and you don't necessarily have, who asked me about this one? Somebody asked, was this you, Anna? Okay, so 6 minus log, you have to remember your log properties on this. This becomes 1. This becomes plus log 1/2. So I can't really combine these. I mean, I could. Why? What? Where are you going to take your quiz? Go to Mr. Hunter's room. He's down there.
Now go to that old white guy.
Right past Mr. Densmore's office. That's what he's there for. To do makeup testing and quiz, and then help our Algebra 1 kids. If we need him, he's a substitute. So if we need him, but he's got a. Oh, I'm done. Okay. Here's what I'm gonna do. I'm gonna split this up. Y'all remember those log properties? All right. If you've got log base b of, let's say, x divided by y, I can expand that with subtraction. And then you've got the multiplication one, which is addition. And you can go either way with these, right? I can go forwards or backwards. I can expand from left to right. I can condense from right to left. The other one is that power rule that doesn't come up on this one, but x to the y would become y times log base. So those are your 3 important log properties that you have to remember to expand and condense. So if I think about those and I look at this problem, I could split this up into log of 1 minus log of 2. Why is that helpful? What is the log of 1? 0. That's always 0. So now I've got 6 minus 1, which is 5, minus log 3, minus log 2, and I can combine these two. 5 minus, what does that become? Divided by 2. I'm going to divide because we are subtracting there. That's the most you can simplify it. Is that what they got? Ooh, no, they got log 6. What'd I do? Top minus bottom. You don't average this. I'm leaving mine. I'm going with mine. I guess they said plus a negative and plus a negative. They factored out a negative. I would stay with where I was. All right, give me something else. Give me something else from your homework. Anything? Because it didn't say find the average. It says evaluate each integral using the evaluation part of the fundamental theorem, which is just antiderivative evaluated top minus bottom. Oh, that's not right. Sorry. No. You're talking about the 1 over b minus a? That's only whenever it says find the average value of the function. Yeah. Otherwise, we're just evaluating. Yes. 31. I like these. You know, but you say that, and I said something Friday. I was like, maybe we shouldn't have pushed so much of the average value, because I'm worried that people are now going to think you always preface it with 1 over b minus a. And that's what you asked me about. You're still good. All right, antiderivative here would be what? What? Oh, yes. Okay. I didn't believe y'all. Negative 5x to the negative 1/5, evaluated from 1 to 32. I just had to wrap my brain around it a second. I'm a little bit slow on Monday morning. Okay. I'm going to plug in here negative 5 times, I'm actually going to pull that negative 5 out to make it a little bit easier. 32 to the negative 1/5 minus 1 to the negative 1/5. So I got negative 5 times. What's 32 to the negative 1/5? Negative means flip it to 1/2. 1/2 minus 1 to the negative 1/5 is 1. Negative 5 times negative 1/2 is 5 over 2. Positive. Positive. It's positive. What else on your homework? Oh my gosh. Lemons are harvested from a certain orchard at a rate. This is, huh? No, we're gonna do trap rule tomorrow. I forgot we hadn't done word problems and stuff. Trap rule tomorrow. I'll have you the program for your computer, for your calculator too. Trap rules, actually, I could actually finish this unit. I don't know that I would have time to test you. I could finish it tomorrow, but we're not testing. We're not testing. We're just going to, we're going to finish out fundamental theorem unit today, and we will introduce trap rule tomorrow. Sorry. We'll miss you. No. What do you mean? I'm supposed to sign off. Huh? Yeah. I'll have a sit down and talk. Liza's not dropping. Fundamental of somebody help Kenzie and Slade out. FTC means fundamental theorem of calculus. That's AT&T.
That's not what that means.
I don't know. Okay. A trace. Lemons. Lemons are harvested. This is number 41 in your book, by the way. This is kind of the application part.
Wait.
Oh my gosh. Yes.
We're not even testing and you're giving me homework.
We're going to test when we get back.
No. Yeah. We said we're gonna be here.
Miguel, stop. You're making me laugh, and it's not funny. You're breaking my heart, Miguel. It'll still be first spot. Why you don't like it first spot?
I'm dropping two, Miguel.
What's fourth?
Actually, I'm gonna join our FTC just like this.
Why did they have that fourth spot?
It used to be second block. I think they moved it to
That's kind of crummy.
Is that a threat?
All right.
He just said we're dying a few days.
Who said it was
Lemons are harvested from a certain orchard at a rate modeled by blah, bushels per hour. All right. For the first 10 hours, how many bushels of lemons have been harvested over the time from 0 to 10? This equation, Noah, this equation's giving me what? It starts with an R. How are you getting your participation grade on your phone? You didn't see your grade last 9 weeks?
What do you think?
If I tell you that this equation models the bushels per hour, that tells me that this is a rate. If I want to know how many, I need to go backwards from the rate. So backwards is antiderivative. That's exactly right. So how many lemons in the first 10 hours? I'm going to do the integral from 0 to 10 of 20t minus t squared d t, whatever the variable is. That's the Wyatt. But there's not a radius in this problem unless you're talking about cutting the lemons open and finding the radius.
I'm talking about the radius of the arc.
Why? This is the derivative. It's the rate. It's the rate of lemons being harvested. So now what I want to do, Noah, give me the antiderivative of the first piece. What's the antiderivative of 20t? So it'd be what? You said it all right, but gave me the wrong answer. You add 1, divide it, what do you get? Let me do this. Add 1.
No, because there is already one there, 2, and then 45 by 10.
10t, keep going squared. All right, you got the next one. Noah, you got the next one. Antiderivative of t squared minus what?
Add 1, and then go.
Is that a trick? Keep going. No, you got it. Yeah, let him write it out, y'all. Let him cook.
If I start off with Jones, I would die. 1/3 t to the third.
Yes! I know, I watched you. I know. All right. Noah, but we're evaluating from what to what? 0 to 10. That's right. So that means I'm going to plug in 10, I'm going to plug in 0, and I'm going to subtract. Yes? Light work. That's what my third block keeps saying. This light work, Miss McGee. How many lemons? How many bushels of lemons? 667 bushels. It's a big basket. All right. Not in a word problem form. This was 41, by the way. Yeah, it was. It says, lemons are harvested from a certain orchard at a rate modeled by L of t equals 20t minus t squared bushels per hour. How many bushels of lemons have been harvested over the time period 0 to 10? They give you the equation, the antiderivative equation. Will you ever have, eventually, not today. Bushels. 20t. For right now, it will, yeah. You're doing 51, I'm doing 52. Are you serious? I have his phone. Whose phone do I have?
That's your phone.
Well, then somebody else has got Logan and Ella hugging.
That's my phone.
Crackers.
What is this?
Find the area of the shaded region. Mark, set, go. It's not a shape, so
That's not the shape at all.
So what about the
Hey, this is
Does it give you?
Okay, use your calculator then. What are you going to do? You have to do 2 equations. You're exactly right. That's why I'm teaching you. Silly goose. So Wyatt's right. We got to divide this into 2 shapes because I have this. It's not a similar. It's not. No. Don't take my drawing. It's not a. The pink area spans from 0 to 1. It is the square root of x. An integral, Noah, an integral gives you the area under the curve. Yes? Say yes, because that's right. An integral gives you the area under the curve. So I go from 0 to 1 on the square root of x, and then to that I am going to add from 1 to what? 2. What is that equation? X squared. This will give me the total area of the shaded region. Does that make sense? That's all you have to do. You'll find those values on your calculator if you want to. Or you can do antiderivative. What do they want you to do? Let's see. It's non-calculator. What's shaded? What's not shaded? Are you sure? Shaded is non-calculator. So if you use a calculator, you can graph these individually and do the area of each one. So if you do this first one, the pink one, what do you get for the area? It'd be antiderivative top minus bottom, yes. from 0 to 1. I got 0.66668. How about this one? I always graph them, and then I go second calculate or second trace, go down to option number 7. Y'all want me to show you on here? Yeah. 2 1/3. Okay. "45 minutes what?" I can speed through these a little
I
faster.
promise you, Joey's class is a lot. Sorry, she's talking to the camera.
Okay. If I did square root of x first, Doja, I'm using yours. Sorry. Graph it. There's square root of x. You see it's really not a semicircle. I just drew it incorrect. Yeah. No. Okay. Second trace, number 7. I'm going to go from 0 to 1. It shades it in for me and everything. There's the first piece. The second piece, I'm going to go back to y equals, and I'm going to do x squared. And I'm going from 1 to 2. There it is. When you go second trace and hit number 7, it says lower limit, so you put 1 and hit enter, and then it says upper limit, so you put 2 and hit enter. No. It's pretty close to 3. It's pretty close to 3. I would round it to 3. It's probably pixelated. It should probably be 2/3. If you do it by hand, what do you get? 2/3, yeah. Antiderivative. Antiderivative of square root of x, which is x to the 1/2, would be 2/3 x to the 3/2, and you do that from 0 to 1. So it would just be 2/3. All right, let's keep it moving, keep it moving. I'm not going to do this one for you, but I do want to set it up for you. Look at this one. This is 54. And then we're going to do a couple of particle motions, and I'm done. 1. No, I'm going to set it up for you. Yeah. This one's a little different. Find the area of the shaded region. Find the area of the shaded region only. Sure. I'm a bit impressed. That's really good. No, I'm serious. That's a really, all right, did y'all hear what he said? To find the area of the shaded region, I'm going to have to find the area of the whole thing. So the whole thing is from pi over 6 to 5 pi over 6 sine x dx. Agree or disagree? That's going to give me all of this. Right? Then I need to subtract out what doesn't have shading, which is just a big old rectangle. I'm going to assume these heights are the same. Let's see. At pi over 6, what is the sign of pi over 6? Go to your unit circle. That's the very first click right there. For 3 over 2. How about at 5 pi over 6? The same thing. So 5 pi over 6 square root of 3 over 2. So now could you find the area of the rectangle? What? Why? I only want that white shaded region. What you gonna put in your calculator? It is 1/2. It is 1/2. It is 1/2. I went. Yeah, sorry. It's 1/2 because it's right here. She's right. It's right here, which has. I know my pen slipped. So this is the length across is longer than the height up. It's clear there over 1/2. Yeah. Sorry. So what's the area? Well, how far across does it span? Because that's pretty easy to look at to tell. Why? How do you get that? How far does it span across? That's right. You just subtract them. 2 pi over 3. Now the height or the width, how high up does it go? 1/2. So what's the area of the rectangle right there? Multiply it. 2 pi over 3 times 1/2 pi over 3. So the area of the shaded region is going to be shaded. The integral from pi over 6 to 5 pi over 6 sine x dx minus pi over 3. And then you evaluate that. And I'm going to leave that for you to do. What is that squeaking? Yes, you can. So you could do negative cosine there and evaluate. You could. You could. It's a calculator problem, yeah. Let's look at 63 and then I'll be done. So, as y'all, what? Negative cosine. Cosine is x, sine is y. C comes before s, x comes before y. If what is negative? No, that would be, it would be negative cosine 5 pi over 6 minus negative cosine. So just change the sign. What's the cosine of 5 pi over 6? So it would be positive root 3 over 2. What's the cosine of pi over 6? We just did it up here, root 3 over 2. And remember, I got to subtract out this pi over 3. What was 1/2? This is the complete and total answer. Your calculator is going to give you an approximation. If it's a non-calculator, you would have to do it this way. If it is a multiple choice, they're going to format the answers that way, so you'd have to know how to do that. But I bet if you do square root 3 minus pi over 3, same thing. All right, let's look at 63 together. This is almost a guaranteed FRQ. I have seen these over and over and over. And the things you get points for with this is crazy. Maybe we should do one of those tomorrow like this. I have a ton of these. 318. 63. They give me this equation, and then they give me this graph.
You have to be waiting right now.
All right. So if h of x, it says that this is, no, it's the same way. Y equals f of x. I didn't hide it.
What is this?
Tell me what I am looking, other than a graph of f of x, in terms of h of x, what am I looking at here? This is 0. This is a 6. Besides the graph of f of x, what in terms of h am I looking at here for the graph? It's the integral of f, but what does that mean in terms of h? Look at that. Look at what they gave me here. This says f of t.
Yeah, but when you do the
What does f, when you do what?
plug it in, FTC.
The first part.
Anti-derivative.
The theorem thing. Yeah.
What are you going to do?
You just plug in that.
The second derivative.
Why? You only plug in the x whenever you take what? dy dx. The what? Which in dy dx is the what? Derivative. So look, if I take the derivative of both sides, do you agree that the derivative of h is f of x? Remember that fundamental theorem, how it goes away, and I plug it in whenever I do the derivative. Okay. Every single time I have seen this as an FRQ, you get a point for writing this and recognizing it. Like a whole point out of 9 just for writing that and recognizing it. They will preface it with something like this and say h of x equals or whatever, Logan Freeman. All right, so you have to understand what you're looking at before you can answer any of the questions they're asking you. I am looking at a graph of the derivative. Are y'all following me? Okay. Find, part A says find h of 0. Why? I can go back to this very first equation they gave me and say, okay, well, h of 0 equals everywhere there's an x, I'm plugging in a 0. Well, guess what? If these two values are the same, it's 0. Yep. Part B. This is number 63, Logan, on page 318. On what interval is h increasing? Notice, now before you answer, we're talking about h, right? So what are you looking for, Anna? Because you're right. Where the graph is positive, because this is the graph of the derivative. So if I want to know where the function is increasing, I look for where the derivative is positive. So for this one, that is from 0 to 6. Bye. Part C. where is H, and think before you answer this, where is H concave up? So this is the what? First derivative. So where is it concave up? You might have to look in your book to see it a little bit better. Where the derivative is increasing. So you're based on, yeah, on their book it's a little bit, on the book it's a little bit more like 9, but that's okay, but it doesn't matter. But yes, you're doing it right. This is when, and I should say over here, because y'all need this for notes. Where is H increasing? This is when the derivative is positive. This one is where the second derivative is positive, which is where my graph over here is increasing, right, Logan? What did I just say? Because he hasn't been in here to hear any of this, and he has not shut up since he walked in the door. Okay, your homework came through at 6 o'clock this morning. You're not looking at this tonight. Whichever one you submitted at 6 o'clock this morning.
I didn't finish the other one because I didn't know what I was supposed
All right, part D. Is H of 12 positive or negative? And tell me why. All right, let's think about this a second. H of 12. We have an equation for H of 12, right? So let's plug it in. That's from 0 to 12 of f of t dt. I'm dragging. You're saying I don't know, but from 0 to 12, if this is derivative and I'm going back, I'm talking about area under the curve. Do I have more positive area or more negative area, or did they look about the same? Okay, well, in the book, if I drew it like the book, it looks more like this. More positive, right? Which would mean that it's positive at H of 12. Okay. How to explain why? We're not looking at slope this time. Think about this for just a second. If I want to find this, that is the area under the curve, right, Logan? From 0 to 12. If it's above the x-axis, it's what? Positive. If it's below, it's negative. So if I add those together, Noah, what happens? Right? Depending on where there is more area is if I'm positive or negative. Does that make sense? You wouldn't have an exact, you would just say it's positive because there's more area. I must be about